In the last video, we set up a struct y and then we converted it to a class. We put in public data, public methods or public functions, and then private data members. This is usually how you use structs versus classes. In structs, everything by default is public, and we sort of usually, almost always, we let everything be public. Classes, we usually have specific public and private sections. And so, just like in Java, the only difference is that well, there's a lot of differences, but let's say one big difference is that you do not say what the visibility of each method is. You have a section in which everything is public, and then you have another section in which everything is private. You can have another public section after this, but usually we don't do that. We usually just have one public and one private, maybe protected sections. Okay, so we run into some error messages, and let's fix that right now. So, well, once again, to recap, we set up get and set methods. The get methods just return the values of x and y. The set methods assign values to the data members x and y. And so when we want to print it out, what we want to do, one way to do it is to do a get x. So this shows you a difference between structs and classes. In structs, by default, everything is assumed to be public, and we make them public. Almost always we make everything public. In classes, on the other hand, we make everything private, so we have to have getters and setters. Once we do that, I think we should be okay. Let's save this, compile it, and everything works, and we can run it, and it produces basically the same kind of output as before, except I just noticed we somehow lost our set y double. Alright, we got somehow we lost our decimal point, everything after the decimal point, and I'm not sure what I did at this point. Y is a double. I do a set y double. Y is equal to yn. Wow, that was hard to catch. Alright, I had an int get y. That was hard. So that's another reason why, this would not have happened in Java. In Java, you would have gotten an error message. But here, C++ just let us do that. Let us return a y that's a double and have the return value be an int. Would not have worked in Java. Okay, so class member functions, you have to declare and then define or implement class member functions somewhere. And we just did 4 simple functions. These are just like other function definitions. It can be after the main, and you can, when you set up the definition, you can either do it right in the class, or you can take it out, and then you have to do this, you have to use the scope resolution operator. So let's do a simple example of that. Let's take one of these out. So let's take this one out. I'm going to copy it and paste it, and now what I have to do is I have to say this method comes from this class y. So y scope resolution operator, and then the name of the method. Okay, let's try this out, save it, compile it, no problems, and run it, and everything works. Typically you will have all methods or all functions declared here in the class and defined elsewhere. So let's just do one more. Let's do this one. Copy that, paste it, void y scope resolution operator set x, and now we can take out this method body. Compile it and run it, everything works. Okay, so that's how, in this case, we only have the declaration inside the class, and we have the definition outside the class. Of course, usually we would have things on separate lines, and we don't need this, I don't think. Let's try that, save it. Yep, no error messages. So this is how we usually do it. It's just that I'm not doing it because now we can't see all of our code. Our code is getting bigger and bigger, and so it's harder to see what we're doing. So everything works just like before. Okay. So the scope resolution operator is used when you define a method. You say return type, the name of the class, scope resolution operator, name of the function, and then list of parameters. And then in open close curly braces, you give it to the method or the function body. Okay, so now there's a whole bunch of examples coming up. One of them is the output member function. And take a look, when we get to it, take a look at the definition. So let's just skip to there. So here is the declaration, member function declaration, and then the definition can be elsewhere. Here it is, void, and then the name of the class, scope resolution operator, name of the function, open close parentheses. If you had parameters, we'd put them here. And then there's the method body, or the function body. Let's scroll back up. There's the beginning. Scroll down. There's the end of that function. Okay, so I'm not going to go over that example. It's pretty straightforward. Let me scroll back up. Okay, so take a look at this output function. That'll get you started with writing functions for a class if you haven't done it already. This is display 6.3 from the book. Okay, so dot and scope resolution operator both do similar things. Dot operator works with a member of a particular object, whereas scope resolution operator works with classes, class names. So it specifies what class the function definition comes from. Okay. So a class is pretty much a new data type. It's just how the programmers, C++ programmers, can set up new types, just like data types, int, double, etc. We have completely new type now. We can have variables of a class type. We just call them objects in our code, and we've done this in Java. We can have parameters of a class type in a function. They can be passed by value or passed by a reference. And we can use our class type just like any other type in most situations. Let's take a quick look at encapsulation. We've done this in Computer Science 235, that is object-oriented programming. The basic idea is that we put a whole bunch of things together, and for example, any data type includes data, a bunch of data, and operations that can be performed on that data. So for example, take the simple primitive data types like int has data value, let's say negative 32,767, just happens to be the value that was, let's say, in some variable. And then you can perform all kinds of operations. You can add another int and get another int out as a result. You can subtract, multiply, divide, mod, and do some logical operations. Like that's relational operators like greater than, less than, and so on. It's the same thing with classes. You can do pretty much the same thing. But we specify the data and the operations that are allowed on our data. So ints and floats and doubles are actually a little bit more clean in the way the operations are specified. It's part of the language. But with classes, when we set up our own classes, we specify which operations are allowed. And so there's also the idea of abstract data types. The idea of abstract, the way it's used is that, well, the programmer doesn't, sometimes programmers who are going to use this data types may not know all the details of how this abstract data type or class is implemented. So when you see the word abstract data type, almost always you want to just think classes. It's also possible you can use structs, but most of the time when you see the term or the phrase abstract data types, you want to think classes. This is abbreviated ADT. We'll use it all over the rest of the semester. So it's just a collection of data values together with a set of basic operations, or classes. ADTs are often language independent. We implement ADTs in C++ with classes. In other languages, we also have the idea of classes, and we could also use structs as well. Okay, so encapsulation also means bringing together as one. That is, you take a whole bunch of things, like let's say you encapsulate all the information about a person into a person class. So for example, name, date of birth, ID, whatever. We put that into one thing. So it's bringing together as one. So when we declare a class, we get an object. An object is an encapsulation of data values and operations on the data. Some of the principles of object-oriented programming that you should know about: information hiding. Also, we use this term in the context of data members. Remember that we want to make all our data members private unless there's a really good reason to make it anything else, like protected or public. That's called hiding those data members. So the details of how operations work may not be known to programmers using this class. So if you set up a class, you may not advertise how all of the operations work, and most of the time they should not care. There's also the idea of data abstraction. That is, the details of how data is manipulated within a class is not known. And this will become really important when we look at more complicated examples of classes. Okay, so remember we said that classes can have public and private data members. Data in a class is almost always private, and a rule of thumb is keep them private. Keep all data members private unless you have a really good reason not to make it private. So this upholds a lot of the principles of object-oriented programming, making things private, making data members private. We hide, so we use information hiding, and we only allow manipulation via the operations. We keep our data structures coherent by doing that. If we know what operations are going to be used and we force all data members only to be used by the operations we supply, we have much more control over how these objects work, and so we can eliminate bugs and things like that. Okay, so we make member functions public, and so those are the operations. And so here's a rewrite of the class that was shown earlier. Now we have all the data members private, and they come last. And before that, in the order in the declaration, come all the methods, and those are the operations. So this is how you want to set up your classes.